Hello. Today we are going to discuss uh, few problems based on applicable approximation method. So find the energy level of particles moving in potential V of x equal to V naught modulus of x, where V naught, V naught being a positive constant. This is what they are giving the potential energy. So we know the classical tunneling point Wkb approximation. So at classical tunneling point, energy is equal to the potential energy. Suppose if I use energy is equal to potential energy, so substitute the in place of potential energy what they're giving you V naught equal V naught modulus of x. Then modulus of x equal to E divided by V naught. Then x equal to plus or minus E divided by V naught. So then arrange this boundary conditions. Modulus of x graph is this one, right? So x1 equal to minus C divided by V naught, x2 equal to E divided by V naught. So this is our WKB quantization solution, right? WKB quantization solution. So where k equal to 2m divided by h class square whole power 1 divided by t minus v whole power 1 divided by 2. Then substitute potential energy in place of v and simplify this equation. Substitute in place of v, they're giving v naught modulus of x. Then simplify this equation. After simplifying this first step, so apply this boundary condition all these things, then you will get simply this. Okay, this is the final answer. So these three equations are very important. This is very simplest problem. I didn't apply any shortcuts till now. So from this solution, I'm going to extract some one or two shortcuts. How we can find the WKB approximation easiest way. If you look at this equation equal to the equation, this maybe I'm going to give the equation number. It's a very important solution I got here. So if you clearly observe here, this energy is equal to some values are there, quantum numbers. 3 divided by 4 is number, n is quantum number, n equal to 1 and so on. I is V naught also, they are already specifying V naught is the some positive quantity. Plus square divided by 2. So the constant. So here the energy is from this, suppose what they are giving potential energy, they are giving this potential energy V naught modulus of x. Then I got answer like this. Energy is proportional to n whole power 2 divided by 3 I got. Observe carefully here. So energy is proportional to quantum number whole power 2 divided by 3 I got here. See, energy is proportional to n whole power 2 divided by 3 I got. If they are giving this potential. For example, if they are giving v of x equal to v naught, okay, modulus of x whole power m. Here I'm going to write formula. Energy is depends on n factor Suppose I'm going to write like this: 2m divided by m plus 2. Okay. For example, if you substitute here, if you look at the here the m is 1. Substitute here in place of m. If what happen if m equal to 2 divided by 3, right? You got this answer. So this is the one of the shortcut I find value, okay, from this solution. Well, it's very useful for shortcuts. Okay. Next formula, I'm going to. I hope you understand what I am saying here. This is our solution, WKB solution we got. From this solution, I'm going to find some shortcuts. So here energy is proportional n whole power 2m by m plus. And one more important parameter is there here. Some function are there. The energy function along with the quantum number. Some another functions also there. Not there also these are some functions, right? So if energy is depends upon that function, energy is proportional to some alpha whole power 2 divided by m plus 2. Here the m is not there. So why m is not there here? So again, I'm going to use here. Suppose this is V naught. In place of V naught, there is no is a constant. For example, not saying specifically this constant, which is why we're giving 2 divided by, so according to this formula. So by using these two shortcuts, this is one, first one, second one. We can solve one or two problems based on these two forms. Okay. So this is the general how to solve by using equation. It will take a lot of time to solve. So if you want to finish one or two 1 minute by mass question, use these two shortcuts. Okay. So one more shortcut is there. We will discuss later. First, we need to discuss this shortcut. You know what? Why we are these are not assumptions value. These are not known value. From this well-known solution, basic solution, we can arrange this. So here we arrange two shortcuts, right? These two uh, formulas. So remember this one. Observe here the E is depends upon some another functions like suppose here we discuss V naught, right? V naught here there is no full power m here. This why I didn't use any factors here, right? So then forgot all these things. Okay, then this is the first formula. So if energy is depends upon n, this is the first shortcut. If energy is depends upon some another factors, the formula 2 divided by. First problem we are going to solve here. The first problem Uh, for example, short. Okay. 2018, they are giving Hamilton of the system which is equal to p square divided by plus modulus of lambda modulus. They're giving options like this: lambda power 5 divided b, option B lambda power 2 divided by 3, option C lambda power 4 divided by b, lambda power 1 divided by. What they are giving exactly, the one-dimensional system is described a Hamiltonian is equal to p square divided by 2 plus lambda x, where lambda greater than the ground state energy varies as a function of ground state energy varies as a function quantum number varies. So use this shortcut. E is proposed some constant. Okay, if you use the constant whole power, yeah, 2 divided 2 divided. So here in m place 1 is E is proportional to 2 divided 3. Answer is P. Just 30 to 15 seconds we can find it by using shortcut. Next one is, what happen if we energy quantum number? For example, 2017 exam they are giving of question. The energy eigenvalue n of a quantum system is potential equal to c x power 6, where c is greater than 0. The constant for large values of quantum number n varies. The large quantum number they are giving the specifically mentioned large. Here the option A there n 4 divided, option B there 3 divided, option there giving n 5 divided 4, option D there 6 divided. So here the energy is depends on quantum number. So use this. So right formula, energy proportional to m divided by 2. 2m divided by m plus, what is the m here? This is m is proportional 2 into 6 divided by 6. N 12 divided by 8 not equal to n 3 divided by. So this is the answer. So these are the two shortcuts you can extract from the general. So remember this. Next class we will discuss. So we will discuss one more shortcut is So I can arrange the nth formula. If I arrange a general based on this general solution. Next shortcut, third shortcut.